Hello everyone, welcome back. This is a continuation of the video series where we are solving the paper 2 of the mock exam prepared by MathsAid. We are asked to find the interquartile range of these numbers. Well, don't let the numbers scare you. It is quite simple. Interquartile range is the difference between the upper quartile and the lower quartile. To find the upper quartile or the lower quartile, we have to arrange first. So we can either arrange as in ascending order or descending order. Let's arrange in ascending order. The smallest number there is 2, then 4, then 5. We have another 5. We have another 5. We have another 5. Then 6, 6, 7, 7, 7, 8, 9, 15, 20. You can quickly count to be sure that you do not omit any number. Now that we've arranged, we can find the position of the lower quartile. The position of the lower quartile is given by n plus 1 over 4. That's the value. So our n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 numbers. That means 15 plus 1 over 4. And that's 16 over 4. That's the fourth value. So the fourth value is actually 5. Yes, the fourth value is 5. When I count, this is the first, this is the second, this is the third, this is the fourth. So that means this is the fourth value. So we can call it Q1. That's the lower quartile. For the upper quartile is given as 3 into n plus 1. Sorry, that's the position all over 4. That's the position of the upper quartile, Q3. So that would mean 3 into, our n is 15 plus 1 all over 4. That's 3 times 16 all over 4. That's 48 over 4, which is 12. Please make no mistake. The upper quartile is not 12. It is the 12th value. So if we continue counting, this is the fourth value, 5th, 6th, 7th, 8th, 9th, 10th. So, okay, 10th, 11th, 12th. So this is the 12th value. 8 is the 12th value. So this is our Q3. So the interquartile range is simply the difference between Q3 and Q1. That is the upper quartile and the lower quartile. The value for Q3 is 8. The value for Q5 is Q1 rather is 5. That means the interquartile range is 3. Option D. In this next example, we are told that a bag contains 9 identical balls. 3 are black, 2 are red, and the remaining are white. If a ball is picked at random, what is the probability that it is not white? Well, once we calculate the probability that it is white, we can easily find the probability that it is not white. So we have 9 as the total number of balls. The number of black is 3. The number of red is 2. That means that's 5. And we have 9 in total. That means the number of white balls is simply 9 minus 5, which is 4. That means we have 4 white balls. So what's the probability of finding, of picking a white ball? It is simply 4 divided by 9. Now the question says, what is the probability that it is not white? So it is the same thing as probability of not white, and that would be 1 minus 4 over 9, and that will give us 5 over 9. There's actually another approach, but let's just proceed. Question 49. The ages in years of 7 girls are 12, 8, 10, 10, 13, 15, and 9. Calculate the mean deviation. Well, mean derivation is also quite simple, but it takes a bit long process to calculate. We need to calculate the mean first. The mean is the sum of 12, 8, 10, 10, 13, 15, and 9 all over 7, which is, when you add everything using your calculator, you will get 77 over 7, which is 11. That means the mean is 11. Now that we found the mean, we are going to calculate the mean deviation by taking away the mean from each of those values. So the formula for mean deviation is the absolute value of each value minus the mean all over the number of values that we have. So that means for the first number, we will have 12 minus mean, which is 11, and that's 1, right? The absolute value of 1 is 1. The second number is 8, so 8 minus 11 is negative 3, right? But since it's absolute value, that means we are going to write the positive value of 3, which is 3. Then we have 10 minus 11, which is negative 1, but we are going to write 1 since we are working with absolute values. The same thing for the next number, which is still 10. 1, 13 minus 11, which is 2, 15 minus 11, which is 4. Then lastly, 9 minus 11, which is minus 2, but we are working with absolute values, so we are going to write the positive, which is 2. Now we are going to add all these numbers together. 1 plus 3 is 4, 4 plus 1 is 5, plus 1 is 6, 6 plus 2 is 8, 8 plus 4 is 12, 12 plus 2 is 14. That means the summation of, okay, I forgot to write summation here. The summation of these absolute values is 14, and of course we have just 7 numbers, so 14 over 7 is 2. That means the answer is 2, option B. And lastly, question 50, the diagonals of a rhombus. Let's say this is our rhombus W X Y Z. The diagonals intersect at M. Okay. So this is the first diagonal, and this is the second. Let me use another ink for this. So we are told that the diagonals intersect at M. So that means this is point M. If MW is 5 centimeters and MX is 12 centimeters, calculate the perimeter. Well, one of the properties of rhombus that you should know is that the diagonals are not the same. They are not equal, but they bisect each other, and they bisect each other at 90 degrees. That means the angle here is 90, the angle here is 90, the remaining 2 angles are also 90. So we can see straightforward that we have a right angled triangle. So if this is 5 centimeters, this is 12 centimeters, and this side WX is length. Another property to know is that the length of a rhombus, all the sides are equal, just like for a square as well. Now, L squared, which is the hypotenuse, is going to be 5 squared plus 12 squared. That's 25 plus 144. That's 169. That means L is square root of 169, and that's 13 centimeters. So since we know that L is 13 centimeters, that is the length of the side of the rhombus, the perimeter of a rhombus is given by 4L, which is 4 times 13 centimeter, and that's 52 centimeter. That's the value of the perimeter of this particular rhombus.